So lecture module 6, chapter 6 from the textbook. Again, application software is real straightforward. Most of us have experience with much of, or even most of this chapter. And having said this, if you're at all behind in the Linux labs, this is your week to catch up. Next week, the pace kind of continues or quickens because it's new content in a lot of areas. And it becomes increasingly difficult to catch up with Linux labs just due to the necessary continual review of past material. Okay, I want to remind everyone that lecture module 6 also has a discussion board 6, and this is where hopefully you'll share with us what you're using, any specific application software, operating system settings, things like that, anything that you do that would be of interest to anyone else in the class. This is that networking. This is where we learn from everyone. So without further ado, I'll head into the textbook material. Now I have added some content, but as in the past, you're responsible for the textbook material. But there's other important information that the textbook doesn't present, so I'm going to do that right now. First, in advance of systems analysis, the chapter forthcoming on systems analysis, we need to understand return on investment, total cost of ownership, and then the differences between efficiency and effectiveness. Now, again, in the past, when we look at application software, we're just purchasing for ourselves. And this is very straightforward. It's far more complex when we're making decisions and purchasing and implementing software for an enterprise. So we discuss return on investment. What's the software cost? What are the advantages? We can talk about cost and benefits. But it goes beyond that, the total cost of ownership. It's actually relatively straightforward, I've said this in the past, to say purchase a server. The expense comes from hiring someone to manage the server. With software, we can go out and we can purchase software, but are there any training requirements? Do we have to train the people in our organization to use it? And that's actually the higher cost. So, and it's a continuing cost because as people come into or leave the organization, new people need to be trained. Societal considerations. Well, digital rights management, end user license agreements, things of this nature we need to be very familiar with. The whole open source software movement. And then location services and privacy. And really that's getting into ethics. So again, with everything, that IT business society triangle, we think about ethics throughout this course and everything we do. Think about security as well. So I presented this in the past, and we don't formally cover this until the chapter on ethics, but I just wanted to remind everyone of the 3 basic ethical constructs: stockholder theory, stakeholder theory, and social construct theory. So again, stockholder theory. If I ascribed to stockholder theory, the only thing I'd really care about is making money for my stockholders. It's not my personal viewpoint. Stakeholder theory. Well, stakeholder theory extends stockholder theory. I now want to, of course, make money for my stockholders, but I'm also concerned about the welfare of my stakeholders. Now, stakeholders are it's kind of nebulous or ill-defined. Is it my employees? Is it my employees and end users? And that's something that, either you or the organization needs to determine. Social construct theory. That means that an organization strives to do more good than the resources it consumes. And again, with ethical theories, as long as you're consistent, there is no right and wrong here. You may believe in stockholder theory, and that's your purview. Just stay consistent with that, of course. I copied this slide from a previous presentation, just so we remember where we're at. The application software sitting up here, recall it's in user mode when we look at, say, user mode versus protected mode that the operating system operates in. So just to refresh everyone's memories. The textbook does not present this. We can distinguish software further between vertical software and horizontal software. So what is vertical software? Vertical software is useful, say, for a specific industry. I give the example of an airline reservation system, Delta. Delta could develop a reservation system. It could probably be used almost right off the shelf by, say, US Air or Southwest Airlines, right? Vertical industry. Within a specific industry, the software translates, it's vertical. Would that vertical software, would that Delta airline reservation system be useful for, say, a taxi cab company in New York City? Probably not, okay? So again, there's the definition and an example of vertical software. In contrast, horizontal software, Microsoft Word. I imagine that Delta uses Microsoft Word within their organization. I imagine New York City taxi cab companies use Microsoft Word. So we're presenting this because quite often we have the possibility of purchasing, say, off-the-shelf software versus developing it, okay? And again, we'll look at this in systems analysis in much greater detail. But with horizontal software, it makes sense it's probably available for purchase already. Okay, so when we look at application software, one of the first things we need to do is look at the software license, the end user license agreement. And again, we as consumers, when we purchase software, it's pretty much understood that we can install it on our machines, but there are very different concerns and restrictions when we take this to the enterprise, to the organizational level. One of the things that has really made this much more complex is the introduction of virtual desktops. Okay, so I'm talking about VDI, virtual desktop interfaces, which of course I introduce is the basis, the architecture of the Hudson Valley Academic Computing Environment, the ACE. So let me give you an example. The former ACE, we had standalone machines, Windows machines. So each machine would have all the software installed on it. So the software license was very straightforward. You had a license for one machine. It was installed there. Students would come and use that machine. Great. But with virtual desktop interfaces, now the software is being pushed down from the server. So a student could log in and use Microsoft Office on one machine, but the next day, use it on a very different machine, but it's coming from a server, and that's the distinction. What happened was with the licensing requirements in the first model, we had, say, 3,000 machines on campus. So we would need 3,000 licenses for Adobe. Now with the latter, we have 12,000 students, and Adobe told us that we now need 12,000 licenses. Okay, Adobe software is very expensive. So you can see that the costs of our infrastructure rose considerably because of this. Just a new architecture, same software, and things changed very much. When we look at the various categories of licensing, commercial software, shareware, freeware, public domain, open source, software subscription. And I added this one. This is not in the textbook, and I will introduce that in a minute. But let's take a look at each one individually. So commercial software, we're very familiar. Microsoft Office, right? Adobe Photoshop, okay? The major players. Developed and sold for a profit. The licensing will vary. Sometimes you get to install it on one machine, sometimes 3, sometimes 5. So again, it's very different if we're evaluating this for just our own personal machines, again, versus a organization. From an organizational perspective, there's a lot more involved, especially with the introduction of virtual desktops. Shareware, freeware, and public domain. The first two, shareware and freeware, are copyrighted. The distinction comes from with shareware, at some point, you're expected by your honor code to pay for the software. Now, some of the shareware software has kind of arbitrary pricing, and they may ask you for a donation. Okay, so you get to choose how much you're willing to pay for it. In contrast, freeware is free, but again, it is copyrighted. Just recognize that. Public domain software, in contrast, is not copyrighted. Essentially, it's given to the public. Now, I did introduce too, one other thing was software subscription. We need to recognize this. In the past, people typically purchased software. Okay, Um, but the industry, of course, recognized that people were not upgrading, so their revenue stream was curtailed. As an example, Microsoft Office. I would be completely fine with Microsoft Office 2007. I'd actually be fine with Microsoft Office 2000. Okay. I never would have upgraded. I don't see the enhancement that they're adding. In fact, they make it more complex for me because they keep changing the interface. So I have to go and research where was that functionality? Oh, they've moved it here. Okay. So unfortunately, the companies weren't receiving any additional revenue stream. Okay. Recall what I said about help desk. These companies would sell something, but then they have to staff a help desk to support it with no additional revenue stream, pure overhead. So these companies saw this, of course, as it just was not a good business model for them. So they moved their model to a subscription service to now you have to purchase on a yearly basis a subscription to use the software. And a lot of this actually came from from our mobile apps. They were the first to implement this. Mobile apps also did something in-app purchases. Quite often you can download the app, but to do anything of any real consequence, you have to make these in-app purchases. So a lot of mobile apps moved to this model as well. Open source software. Well, open source means, implicit in the title, is that you're also getting the source code along with the executable. Now, open source, there are some paid, but for the most part, you can obtain it freely. We read in our Linux labs about the Linux GNU GPL, the General Public License. And that was revolutionary. Because what Linux did is, well, here's the executable and here's the source code. But they created this license agreement, the GPL, which stated that if you improve or enhance the source code, if you pass the source code on or the executable, you're obligated to pass on your enhancements, which is real interesting, actually. Um, so one of the things that we have to recognize, and we'll cover this again in systems analysis, that open source software, while you can say download it and use it for free, there is a cost. One in support, it's that infrastructure. Let's say something like Microsoft Windows. If you purchase Microsoft Windows, you get support. Should something go wrong, you can call Microsoft and access their tech support. With open source, there is no organization that is obliged to help you with your support. You're really at the behest or the mercy of the open source community. Should you have a problem, you can put it out there and say, I'm having this problem. Can anyone help me? And I'll come back to cover this in security. That in itself represents a security vulnerability. Why? Because you have to divulge to the world, I'm having this problem. I'm putting it out there on, say, a message board. I'm running this, and I'm having this issue. Well, you've just broadcast to the world what you're running, which if there are any hackers out there, they now have a target vector. I know you're running this architecture on this, hardware. What are the known vulnerabilities? What are the known attacks? So buyer beware, even though we're not paying anything for this open source software, there are costs involved. And I'll talk about security, return on investment down the road in the chapter on security. Very difficult thing to evaluate. So installed versus cloud software. Again, we can make this distinction now too. With installed software, of course, I better have the resources to run it. Things like CAD, computer-aided design, they require kind of a hefty desktop. But then again, with computer-aided design, I don't think I'd want to run it through a cloud because of the interconnection. Recall, the limiting factor in computing are the interconnections. With cloud software, I'm reliant upon that internet connection to that cloud server. Now, some cloud software can work in an offline mode, Google Docs. So again, there are two different approaches. With the cloud software, you're using cloud software. The other question is, where are you keeping your files? Okay. Of course, if they're in the cloud, then someone else can sift through them. Now, and I'll take a break here. Um, we know, of course, about the acronym IT, right? Information technology. Up until about 4 or 5 years ago, the focus was always on technology. When you thought about an IT company, it was the technology, right? Or if you're a IT technician, okay, you're working on the technology. It's changed. In light of AI, machine learning, deep learning, the focus is now on information. Whoever has the most information actually has a competitive advantage, because now the machine learning can sift through, find relationships, correlations that never, were previously unknown, and that gives you a competitive advantage. We're going to look at this in much more detail. The last week in our emergent topics, we're really going to dive into AI, the deep learning algorithm, and see what's going on in the world. Because there are major concerns there. So cloud software, delivered on demand. Again, probably the best example, Google Docs is the best example. Um, Now, it's rather unfortunate, again, as I introduced in week one, this discipline, we use acronyms. So software as a service, SaaS. Okay? But cloud-based storage as a service is also SaaS. So a little, opportunity for confusion there. Okay, cloud software. So we spoke about, ubiquitous access. The servers, of course, if we're storing our files there, will likely back them up. Okay, removing that from some, responsibility for on our behalf. Security is a big concern. You know, um, and again, I'll defer talking about security until the chapter on security. But if you really are taking advantage of cloud software, a virtual private network (VPN) application is probably a good idea as well. Uh, and the textbook presents crapware. Okay. Um, you know, I've always thought this to be unethical, is when you download some program, you get all these, you know, side along programs, apps with it. Um, I guess just beware and really read. If you're downloading software, really read through. Read through, of course, the end user license agreement. But quite often, some of these sites will be real deceptive. You're downloading some software and that link may be very small, and then you'll have some other big button that says download now. And in small print of saying, oh, you're also downloading this other stuff. Or be careful of check boxes that are checked by default. So just be aware of this as well. When I download software, I try to go to reputable sites, cnet.com, things like that. But even CNET these days, I'm noticing has some side along, lack of a better word, crapware that's trying to be tagged and downloaded along with it. Software suites. We're all very familiar with this. And the remainder of this chapter, I'm going to move through pretty quickly, again, because we're very familiar. Most people have had, Microsoft Office, Excel, things like this down in high school, or use it in their work environment. So a software suite is just a collection of programs. Of course, the best example, Microsoft Office, Microsoft Word, Excel, Access, and PowerPoint. Google Docs has the same thing, although they don't have a database associated with that. And Apple too has a software suite, Pages and Sheets, and Present. So let's see, with a software suite, we are seeing common software commands, but you'll see a lot of these software commands actually consistent outside of the software suite as well. As an example, in Windows, Control-C, copy. And that'll work pretty much on a web page throughout anything on Windows. Control-V, paste, Control-X, delete, things of this, or cut. So word processing, I'm not going to really present anything here. I'm aware that everyone here has probably used Microsoft Word and or Google Docs or Apple Pages. The functionality is consistent across the various incarnations. So the ability to spell check, grammar check, format, page breaks, word wrap, all of these things are pretty much straightforward. I predate word processing software, by the way. Some of the first papers I had to write were without this. Much more difficult. Spreadsheets. Okay. Spreadsheets are invaluable in business today because they allow what if analysis. They also allow for accounting. When you look at accounting, accounting is the communication mechanism of business for communicating financials. Okay? But also closely associated with this, the what if analysis for planning. So listed are here, but here are the major players, so to speak. When we look at spreadsheets, again, they're for performing mathematical functions. So a few things you need to know at this level. The worksheet is the single spreadsheet. If a workbook is a combination, multiple spreadsheets. And the cell is the intersection of the row and the column. So very similar to computer memory. Call computer memory the byte, right? It had contents and an address. Similarly, a cell in a spreadsheet will have contents and an address. The address will be the intersection of, in this case, A1, the column and the row. Rows will be numbers, columns will be letters. Let's see. Similar to programming, spreadsheets require significant documentation. You should be able to look at a spreadsheet and it should be documented so that the intent is clear. It should not require you to go and investigate or say reverse engineer to find out what the spreadsheet is doing. Okay, very similar to programming, documentation. Just a note, CMPT 115 is really gets into spreadsheets and what if analysis and analytics, really getting into the basic constructs of predictive analytics. Please, perform your due diligence in this course. Understanding spreadsheets will assist you throughout your professional careers. I have students who graduated from the program and went to work in Boston doing nothing but Microsoft Excel customization. And they started at $80,000 a year with just a 2-year degree. Now, granted, Boston is very expensive to live, but still, if you know Excel, Microsoft Excel, just even that, you'll be very well positioned. So in documenting a spreadsheet, labels, of course, format things well, constant values. What are we talking about with constant values? Things like calculating a, car payments, if you're going to finance a car. The interest rate would be that constant value. Spreadsheets will contain formulas and functions, okay? Functions are predefined. They're essentially known to the spreadsheet. In that sense, they're very similar to Linux commands, okay? Commands are predefined, right? ls, sort, who, things like that. In a spreadsheet, sum, average, min, max, concatenate. Both formulas and functions will begin with an equal sign. Here, of course, we're looking at functions, so we have that predefined function name. And again, this follows or adheres to the mathematical definition of a function. Y equals f of x, right? When I say f of x, that x is in parentheses, okay? So here we have the function sum of range. Now, within spreadsheets, we need to understand the distinction between absolute and relative cell referencing, okay? Relative, of course, means it's moving, okay? It's relatives to something else. Absolute is static. It does not change. So to make a reference absolute, the column or the row or both are preceded by a $sign. So let's take a look. The best way to illustrate the difference is to actually look at examples. So here we go. In the first one, we have a correctly programmed, using the word programmed, relative referencing example. So here, this cell is highlighted, and we see its result, but that result is based on the formula, not a function, okay, equals B2 C2, okay, B2 plus C2. So we have the contents of B2 plus the contents of C2. What you may notice here is this little small box in the lower right-hand corner of the highlighted cell. Okay, this is what's called a fill handle. And what the person would do is grab this with their mouse and then drag it down. And this would populate the cells beneath it. And the cells beneath it would be populated, but since I went down, the row numbers would change. So this value, 1300, would be the sum of B3 plus C3. And this sum of 2100, or the value of 2100, would be the sum of B4 plus C4. So you can see how the row numbers would change as I fill down. Relative, okay? Relative means that the column numbers, letters, or the row numbers can change as I drag them. Because I drag them down over rows, the row number would change. Very rarely, but some people will make things, say, on a line, so you actually drag across columns. So again, when do we use absolute cell references? When we have some constant, like an interest rate, okay? So here is an incorrect application of absolute cell references, okay? So the $B, $2 plus $C plus $2 would just keep adding 200 plus 600 to each one of these values. The better way to do it, of course, would be, here's a division example, and we have essentially a constant that would be held in D5, okay? So as I stated, spreadsheets are used for what-if analysis. And you probably, even if you've never used Excel, you may have used one of these and not even known it, okay? Out on the web. Again, you're computing car payments, okay? What if? What if I put 4,000 down and I apply the loan over 4 years? What if I put 2,000 down and apply the loan over 5 years, okay? Just by plugging these numbers in, once the formulas and functions are set, allows you to do this type of what-if analysis. And again, we're going to look at this in systems analysis and design. Organizations are using this, of course. Well, what if we purchase this new manufacturing machine? Okay. Well, the manufacturing machine is going to cost money, but maybe it'll lower the cost of my products per, instance. When will I break even? When will I show a profit? So this is the basis and the need for what-if analysis. Database concepts, pardon me. Okay. Again, this is just going to be a superficial coverage of databases at this juncture. Forthcoming, we have an entire chapter on database management systems. In the course of this curriculum, the CIS degree, are 2 other courses on just database management systems. There are master's programs devoted, full master's programs devoted just to database management systems. You can do master's thesis work or PhD dissertation work on just small subsets of database management systems. That's how large this area and discipline is. A few things to note. Databases form the foundation of management information systems. When you say, look at the college's registration system, the class schedules, all of these things, they're all stored in a database. We're going to learn that today's web, the dynamic web, the Web 2.0, which I'm not going to define at this juncture, I'll wait till that chapter, is actually based on a 3-tier architecture. And at the base of that, or bottom of that architecture, is a database, okay? The web doesn't have static information out there. When I go to ESPN.com, There's not a page, HTML page there waiting for me to download. That page is actually going to be constructed dynamically, pulling items from a database and then constructed on the fly and then sent to me. And I'll discuss that in much more detail when we get to that chapter. So when we look at databases, I'll introduce the word entity, okay? It won't mean much at this juncture, but essentially an entity is represented in a table. So looking at tables, which of course are comprised of rows and columns, it would look like that possibly it's a spreadsheet. It's not. Many people use Microsoft Excel improperly as a spreadsheet. Excel is not a database application, okay? Databases go far beyond spreadsheet functionality. So if I look at the basis of a database with the table, understand that we have fields columns and rows, which we refer to as fields and records, okay? So fields as a column, single type of data. But again, it goes beyond what Excel, what a spreadsheet can do. A spreadsheet, of course, you can format that column. You can make it currency, things like that. But in a database, you can actually give it domain type representation. So what do I mean by that? If you look at, say, bank accounts, okay, you could have an account balance. Of course, that's going to be a column, okay? But there are additional constraints. Maybe it's a checking account that must have a $500 balance in it. So I'm not just saying it's currency, but I'm actually giving more criteria to what the domain actually is. Database management systems, by the way, is based off relational algebra. It's actually formal mathematics, that and set theory. And again, I will present this when we get to database management systems. At this level, just today, all we need to understand, databases, well, they're based on entities, which are tables, represented as tables. And the information is presented to us in columns and rows, and these columns and rows represent fields and records. Records are related information. So as an example, I could have an individual. So I'd have a column for their last name, a column for their first name, maybe social security number, phone number, et cetera, et cetera. So you can see on a particular row or record, it's related information about that individual. So moving beyond tables, and I won't get into the normalization now, we also need to extract information and of course update it, put information in. Okay? Queries. Queries allow us to both extract information, and the textbook doesn't tell you at this juncture yet, but also put information in. Okay, that would be an update query. Again, we'll get to this in that formal chapter on database management systems. Reports. Reports we tend to think of as static. Okay, I get a quarterly report. I get a sales report at the end of each week or every month. But we should recognize the information in these reports are actually coming from queries, questions we're posing to the database. It's just that we're posing them at predefined or predetermined intervals. Now, what the textbook doesn't present at this juncture is forms, okay? Forms put information or allow you, give a front end to put information into a database. And again, I'll present these when we get to the chapter on database management systems. Presentation graphics. I'm not going to say much. You know, I use Microsoft PowerPoint. Much or many or even maybe all of you have used Microsoft PowerPoint or Google versions or Apple versions. Okay, so they allow us to present information as if we were, performing a presentation. There are educational constructs. There's psychology within creating a good presentation, and of course that goes beyond the scope of this course. How do we present information? Won't get into that. So, moving on. Graphics and multimedia. So there are a lot of different programs out there for graphics and multimedia. For graphics, of course, Adobe Photoshop is probably the best known. It's kind of an industry standard. But no, there is an open source version or alternative known as GIMP. And GIMP will have essentially all the functionality as the very expensive Adobe Photoshop. It may be a version or so behind the latest and greatest that Adobe is coming out with, but it's very good. It's free. Multimedia, there are a lot of applications out there. On the Apple side, there's iMovie. I'm not familiar with, I forget what the Windows version is for you know editing movies. Graphics software, typically we usually have a couple graphic artists in the class. Hopefully in the discussion board 6, they'll share with us what they're using. Again, it's kind of a great user review, and that's kind of become the model of the web, of course. I look at user reviews before I buy something. Well, these of course are strangers. So someone within the class telling me they use this particular software is far more credibility, right? We have relationships with these people, so we're going to trust them more. So types of graphics software, painting programs, graphics editing, things like this. Vector tracing for converting bitmapped to vector type programs also. Audio capture and editing software. Again, it's out there just like video capture. It's out there. There is, if you're unaware, video capture software that would allow you to record something streaming on your computer real time. Okay, and similarly, audio as well. And then of course you can edit it. So I'm not really talking about, say, like a YouTube downloader. That's a little different. That's actually downloading the file, essentially a right-click save as type functionality. Video editing, DVD authoring software, I'm not going to say much. Some operating systems will actually be built in. Mac actually has DVD authoring software built into its operating system. Media players, I'm not saying much here. iTunes, whatever you're using on your Android device to play songs. So again, I'm not saying anything further on that. So this kind of repeats, graphics, multimedia, and the web. Again, there's a lot out there. Again, the best graphics, Adobe Photoshop, although GIMP is just as good. And again, these programs continually evolve to take on more and more functionality to not just edit, still photographs, things like that, but also video. We've seen that. Lastly, remote access software. Incredibly useful. The ability to access your software at work from home or your computer, or you're down, Florida spring break and you want to grab something from your desktop sitting at home. Again, most of us, we've moved on to notebooks, things like that. We'd typically take it with us, but this is good functionality. However, if you move to use remote access software, security becomes a major concern. Okay, so make sure you lock down your systems well. Good choice of passwords. I would use a virtual private network. All of these things. So again, that's all I have. This chapter is very straightforward, application software. Again, but take this opportunity, please. If you're all behind your Linux labs, beyond this week, if you're behind, it's very difficult to catch up. And if you're behind many labs, this is maybe your last chance to catch up. So please take this opportunity. Of course, if you have any questions, let me know. That's all I have for today.